Welcome back, everybody. I think we can start. So my name is Sergey. I'm with 4D France, and today we're talking about probably your least favorite subject, I guess. Same story, in the office. This is probably the most hated subject too, because it's just so difficult to deal with networking errors. Just by the nature of network, the problem is not really fixing the error, fixing the problem. The main difficulty is in actually pinpointing the problem and figuring out what the problem is and where it comes from. We did some architectural changes in V15. We've added a couple of features, and we're actually working on more features to make it easier for you to figure out what's going on and what the problem is. And then also we give you some tools so that they will not only help you, but they will help us. You can help us figure out what's wrong. Because again, when a network error happens on one client machine, thing is, it's not necessarily on that client's machine. The problem, the original problem, it can happen somewhere else, and then as a side effect, it'll propagate to one of the client's machines. One thing I would like to just say a few words on are our timeout, network-related timeouts that we have. And it's been a source of confusion a little bit. We talked about it a few times during previous summits. It's one of those things that technically is supposed to be completely transparent, and you don't even need to know anything about them. But once in a while, unfortunately, you need to dive in and see what's going on and really to understand the kind of things you're seeing. Is it a real problem, or is it a side effect of the standard behavior? So from V11, we've changed the networking in such a way that we went, of course. So pre-V11, we were single socket clients. That is, a 4D client application would have only one single connection to the server, and that's it. And all communication would go through that connection. So that connection was pretty busy, actually. But for you and for us, when a problem happens, it was kind of difficult to see which process it's associated with, which virtual connection, which 4D method caused the problem. And for this and for other reasons, starting from V11, we actually introduced this notion of, we got rid of tunneling a little bit, and we gave each user process its own connection. So now it looks like this. You have multiple connections. The amount of traffic is pretty much the same, but it's spread over multiple connections. So some of them are active, some of them are exchanging data once in a while, and other connections actually maybe send a couple of bytes, and then they just sit there doing nothing, really. So they're idling. And so we said, since the connection is not doing anything, why keep around the connection? Because with each connection, we have a thread associated on the server side. So it uses CPU resources. Because the thread is there, it's waiting for incoming data. So it's looping, it's scheduling, it takes CPU time. And then it has resources for that thread, the memory and file descriptors, whatever. So we said that's kind of waste. And sometime in the end of V11, beginning of V12, we've added this idle timeout, which basically it's an internal mechanism which is completely transparent to you and completely transparent actually to the application level. It detects sockets that are idling, that are not doing anything, that are not sending and not writing anything. And that internal mechanism actually detects those sockets and closes them. So one of the reasons to do this was to save resources, but more important reason was actually the modern routers and firewalls are very, very aggressive. Okay? Even without, by default, when you install it, the default configuration is pretty aggressive in terms of socket management. Basically, a router or firewall will catch and track down and keep track of every single socket that's opened on the network. And then it will look at the activity of that socket. And if a router detects, or firewall, or any other software you may be running, even antivirus software does this once in a while, it'll detect an open socket that's idling, that's not doing anything at all, and it will actually send a reset packet to either a client or the server. Basically, a man in the middle, a bad man in the middle, will see that there is no activity, looks suspicious. I'll probably just go ahead and close that connection. And of course, from the point of view for the server and for the client, it's very generic. It just means, hey, connection's broken. And this is a bad thing, because for the client, connection's broken is a death sentence. Basically, the client says, critical network error, click OK to restart. That's the only option you have. So for that reason, also, we've introduced the idle timeout. You don't really need to change the timeout's value. It's set to 20 seconds, and it works 90%, 99% of the time. But if you ever decide to change the value of that timeout for whatever reason, keep in mind that your hardware on the network may be too aggressive, and if the new timeout you set is too long, if it's longer than the timeout of your routers and firewalls, then you may have started problems. So whenever you're dealing with the networking problems and you see this dreaded critical network error dialog, the first thing to check is everything fine with your timeouts. Okay? Another thing that's new in v15 is that the networking layer, the new networking layer, is actually everywhere now. It's not only with DB4D and SQL as before, but even the application layer uses the new networking by default now, which means through all those three stacks, application, SQL, and DB4D, you'll have those connections that automatically disappear and appear and disappear. It's completely transparent. One of the side effects, though, especially in Windows, which you might see, is if you look at the system log files, or if you look at the firewall warning files, you might see either error messages or warnings saying that that particular application is opening too many ports, too many sockets, and closing too many sockets. This is not a real problem, okay? So you can sort of ignore those messages. And especially in system log files, you can identify, the OS will either list, it depends on the version of Windows, it will either list the process name, the application name basically, the .executable, or it will give the port numbers. And for the port numbers, the standard port numbers, unless you change them, are 19,812, 13, and 14. So if you do see system warnings saying there is unusual activity on the socket level for that application, don't worry. For v15, this is actually pretty normal because, well, it depends on the type of the code you're writing. But if you have a lot of networking requests, if you communicate often with the server, it may happen that we will close and open a lot of connection during the lifetime of the application. And so the system, I think, I saw this a lot on Windows. The Windows thinks, hey, the server might be under denial of service attack because there are plenty of sockets being opened, closed, but that's fine. If those messages you see in the logs are related to 4D or the ports 4D is using, that's totally fine. So that idle parameter, idle timeout is controlled by database selector 54. And as I said, most likely you will never have to modify it. We use this keyword postponed to describe a connection that has been temporarily closed. The physical connection is closed, but the real connection is, of course, the logical connection is still there. So we don't use that keyword often in the documentation, but whenever you see that mentioned, it just means postponed connection is the one that's idling, that hasn't been doing anything for longer than 20 seconds, and we just close it ourselves internally. We had a few bug reports, we had a few questions, so eventually we just decided that in v15 we're going to expose that status for the process, okay? I don't know, can you see that on the screen? Yeah. So this is the monitor on the server, and we have a list of processes. And those two at the bottom, these are from my client. I just connected my client, and I left it idling. Okay, I'm not having any forms. I'm not having any processes running on the background. And so after 20 seconds, the usual status, like active, running, waiting, whatever, waiting for the event, it has been changed to postponed. So don't be surprised when you see this in v15. It basically means everything's totally fine. Okay, the process is there. It's running. It's not using any network. And it doesn't really mean that the process is asleep or really blocked or something. It might be doing some calculations. It might be communicating with something else locally. But it's just that there is no network activity at all. And so that's why the status is set to postponed. And so as soon as you as soon as you do something within that process, within that user process, any sort of request to the server, it will automatically reconnect to the server, and the status will go back to active. Okay? So don't be surprised when you see this in the new monitor. One other timeout that we actually can see on the interface in the settings of the server, it's the one that's controlled by database parameter 13 and 14. This is basically a response timeout parameter. That's the value that we use to detect networking problems when we expect some data. Okay, for example, when I send a request to the server, I expect, even if there is no data in response, I expect at least the status and potentially the error code to come back to me. So I'll expect some, I don't know, 12, 15 bytes to come back. Or if I send a request and I get the status back, and it says you're going to receive lots of bytes, okay? But the first packet contains only the first few ones. So I know, I'm sure internally in my code that I will receive more bytes. And if I keep reading, and there is no data for that timeout, which is set by parameters 13 and 14, then I assume something's wrong either on the server or on the network, and then the client simply, again, produces a critical networking error. All of that now is actually exposed in the application log, because we made an effort to log as many things as possible in the log. It's the usual. It's not a new file. It's not a separate file. It's the same application log. But now we log much more stuff related to the network, so that whenever something happens, and if you activate the log, you'll be able to tell if it's a client-side error, is it a server-side error, is it a problem somewhere in between. But the idea is with v15 to give you more tools and more information in the log to be able to tell, to detect not what the actual problem is, but even earlier where the problem comes from, okay? Those tools are available only with the new networking, and it's actually, if you create a new database in v15, that's what your new mode is going to be. Okay? So by default, a new database in v15 will be using the new networking mode, networking layer. If you migrate from previous versions, then you will keep whatever setting you had in v14 or earlier. So most of the time, I guess, by default, it will be the old networking. But if you go to the settings, can we zoom? Yeah, we can zoom. So if you go to compatibility settings on the server side, there is a new checkbox whether or not you want to use the legacy network layer. Okay? This is a setting that requires a database restart. So if you enable it, then you have to restart the application in order to take advantage of the new networking, or go back to the old one. And yeah, one more hint, lest I forget. If you ever file bug reports now or TAO cases with us, please don't forget to mention which mode you're running in. if it's even remotely related somehow to, you think it's related, maybe related to networking, just make sure you log that information. And don't hesitate to activate the application log file. If you know how to reproduce the problem, please do activate the log file. Tell us which mod you're running in. And send the log file, because there is so much more stuff in it, and it will be really helpful. Because we do try to reproduce the problem locally when we receive the description from you guys. But it's such a sensitive subject that even the smallest change in configuration, okay, the smallest delay that's different, the timing, the order in which you click the buttons, the order in which the clients are launched, the network is so sensitive that the slightest change can actually alter conditions, okay? And sometimes we're simply having troubles reproducing your exact problem. Sometimes we do reproduce it, but then even internally we did this. When we compare logs between different subnetworks, we can actually see, even though we can sort of reproduce a very similar problem, when we look at the logs, we see that the events, the order of the events, and the messages and the errors are actually different in the logs. So please always activate the logs when you're tracking down the problem on the client and on the server, as a matter of fact. And send those with your bug reports. I'll go in a bit more details into logs a bit later in the session. The thing about this on-off checkbox is that if you create a new database in v15, that compatibility checkbox is not even exposed, okay? It doesn't even exist. But you can still change the mode using the new database settings parameter, 87. And you can, of course, you can pass a 0 to disable and 1 to enable the new networking. So even for new databases, you can still change the mode, with the exception, of course, of, and we documented this very well, with the exception of Mac 64-bit server. This one is running exclusively with the new networking. In fact, the old networking is not even compiled into the binary. Okay, so there is no way to switch back to the old networking on Mac 64 bits. Okay, so even if you're migrating from v13 or v14, as soon as you do this on Mac 64 bits, no choice, you are on the new networking. Again, in terms of tracking down problems and figuring out what's going on, don't hesitate to play with that checkbox or with that setting just to see if it changes anything, because the code is very much different internally for the old and for the new networking. So you might not find the actual reason for the problem, but maybe you will have a temporary workaround that will, prevent you from blocking the application, that will help to run the application and avoid downtime. So as I said, basically now with v15, once the new networking is activated, it's everywhere. It's in SQL and DB4D as before, but also at the application level. And so the thing with idling, it is everywhere on every single protocol within 4D. And we already had sort of almost bug reports filed to that, because we had, even internally, we had, and externally too, we had reports saying that I have a server with hundreds of clients connected, and I'm experiencing some problems, so I'm tracking down statuses of my clients. I'm looking at the state of the network, and I'm looking at the server, and I can see that even though I have hundreds of clients connected, I only have, like, I don't know, a few dozens of sockets opened, which is not normal. It is actually. This is one of the changes too. If you look at the open ports and open sockets now with v15, you're going to see much less open sockets, and this is normal. It doesn't mean that, because before, and I think we even have a small tech note on that. Previously, the advice was if you're tracking the state of your clients and you see the amount of sockets, then you have to have a certain number of sockets per client. And if you see less, it means that some of the clients has crashed. And this is no longer the case with the new networking. So something to keep in mind. It is perfectly normal for the server now to have very, very few connections, even though you have lots of clients connected, which is actually pretty awesome because the less connections we have actively, it means the less threads we have to loop through, the less threads we need to schedule. And so the server has more CPU to actually handle the real tasks. Funny story, this is actually was the case. That's why I was saying we almost had bug reports. We have our own internal bug-based server where we track all our bugs. And at any given time, that server has at least 100 connections because pretty much everybody in engineering, in test, in tech support, even sales sometimes, we all have bug-based client opened, okay? Developers, once in a while, we need to look at a certain bug report. We need to maybe download resources associated with that bug report. Testing guys, they need to modify some information, add some new stuff they discovered about the bug. So the server is being used, but each particular user is, I don't know, I spend maybe 10, 15 minutes per day within the bug-based client, and that's it. Other than that, it's just sitting there doing nothing. And when we were working on some other unrelated problems with the bug base, I had the guy who's responsible for it come into my office and say that there's a major problem because he doesn't understand what's going on. He has over 100 clients connected, but only 7 sockets really active on the server, which doesn't make any sense. And I assured him, and I assure you, this is now in V15, it's pretty normal. So if you use a command line or use any other UI tools to look at the socket status on for this server, it is perfectly normal to have relatively few connections, relatively few open sockets in comparison to the number of clients you're running. One thing, OK, we can talk about that first. So now that the new networking is pretty much everywhere, OK, on all the protocols, all the levels within the application, we're capable of closing transparently every single connection, okay? And the next logical step, of course, we can finally tackle this nasty problem of operating system going to sleep, and that's why it was mentioned today during the keynote. This is one of the, I think it's kind of small feature, but I think it's really, really important in V15 that, and I think it'll be available with R4, if I'm not mistaken. Now the sleep events and wake-up events are handled properly. We do our best to make sure that whenever we receive that sleep event from operating system, we do the necessary cleanup. We notify the server that every single process that we're running, every single user process is going to sleep, so we disconnect gracefully. The server cuts everything on the physical level, but keeps all the logical state and all the sessions and transactions and everything associated with the client connection. It keeps it in memory. And when the client wakes up, when the OS wakes up, the client gets the notification, and it reestablishes all the necessary connections. Okay, and so hopefully, really, within last year, to be honest, I haven't had a single email concerning application sleep, because before that, I would be constantly receiving those emails at least once or twice per week where people would say, hey, I went for lunch. I left my bug-based client. As I said, bug-based client is open on everyone's computers within the office. And so they go to lunch, they come back, they open it up, it wakes up, and the client says, hey, critical network error. And the only stupid reason for this is that the OS hibernates on a very low level. It cuts everything. And if we don't take care of those connections, we're basically dead. We need to restart the client. And once we activated it internally, I'm seriously, within a year, I had no messages about the errors related to sleep. So hopefully, this will be a huge relief for you, too. You should see much less errors and less messages from your users saying that, hey, I had this, I went for lunch, and I come back, and there's this unexpected message. I don't know what's going on. Now, this is not 100% foolproof because the OS never gives us any guarantee in terms of how much time we're going to have from the moment we receive the sleep notification to the time where the OS actually goes to hibernate. Okay? In my experience, 99% of the time, and even more than that, we have a pretty good slice of time. We get 2-3 seconds, which is even for the heavy client, for like client that does a lot of processes and does a lot of activity, that's fine. That's enough time for us internally to close all connections and to go to sleep. But other times, again, I don't know why, especially on Windows, we get like literally 100 or 200 milliseconds to do the cleanup. And the OS, even in the documentation of Windows, it says, you will receive this notification. You will probably get a second or so, but we don't give any guarantee as far as that second. You might receive like 50 milliseconds, and that's it. It really depends on the state of the OS. I've seen it maybe once really or twice when that happens. But the good thing is, first of all, hopefully now you'll have much fewer errors related to the sleep. Okay? And then even if you do receive messages from users saying, hey, there's this weird disconnection, the annoying part is that they may forget to mention that happened after the OS woke up. They may just say, I'm getting this error message all the time. I'm just working, I'm getting this message. But in reality, it's actually only after sleep. Now you will see those messages in the application log. So whenever the client goes to sleep, it will log a message. Whenever it wakes up, it will log another message. So if it goes to sleep and you see and we actually log also the connection count too. If you see the connection count is not at 0, it means we didn't have enough time to disconnect. And so you can explain to the user, hey, really sorry, but there's nothing we can do because your OS just went to sleep too fast. And the only way to work around that problem is just either extend the timeout at which it goes to sleep or simply never put your workstation to sleep. You will have a full proof. You will have a proof within the log. You can show to the client to say, hey, this is not related to our code. This is not related to the binary. This is simply your OS going to sleep too fast. And we can zoom in. So same story with the status of sleeping processes is we now do expose it in the system in the server's monitor, and it's a new field in the list box here. We say that the client is sleeping. It's a simple way for you to see who's doing what and other any machines are going to sleep. And you will, if you need to do any sort of maintenance or you need to restart the database, you will actually see who is there and who is not. So if someone's running something critical, you can actually notify the person and say, hey, look, if your database in a certain sensitive state, your client in a certain sensitive state, go ahead and wake up, do something, and then I will be able to relaunch the server. This is just a zoom in on. So you can see the IP address and activity sleeping. It's a nice activity. I like to sleep. Also, we showed this during the keynote. There is a new radio button that helps you deal better with the sleeping users when the server quits. Okay, you have a choice now do you want to wait for everybody to quit? Do you want to wait only for the active clients to quit and you don't care about sleeping ones? So you have a bit more choice how exactly you're going to deal with clients that are sleeping when disconnected. Of course, if the OS is asleep, then that client is gone, really. There's nothing you can do. It's not accessible anymore. So whatever messages you have to send to that client, they will not go through. They will be accumulated on the server. Okay? If you do execute on client commands, same story. That message will be cached on the server, and it will be kept on the server until the client wakes up. And when the client wakes up, it will receive a whole bunch of information, all the server-side events, all the messages, execute on client commands. It will receive all the structure updates. It will receive all the resources updates. So it might so happen if the client was asleep for a while, it may take a few seconds for that client to actually process all those update messages, okay? So it will look kind of frozen. So don't worry about that, 2, 3, 4 seconds, depending on the number. I mean, usually it's just instantaneous. But if you really, I don't know, spend hours modifying the data structure, there's lots of new stuff, lots of new tables, fields, then that client will be sort of bombarded by a whole bunch of small messages saying, this table changed, this resource changed, you need to do this and that. So it may take a while. So this is pretty much normal for client that wakes up to take a small pause to be updated. OK, the cool thing is this new application log. Well, sorry, not the application, the new information that we dump into the application log. The selector for this log is as before 79. Okay, it's the same old application log we all know and use. There is a new database parameter that comes hand in hand with the old one. It's selector 90. And this gives us the rotating log. Because we saw that while logging everything related to network, it actually increases by a good margin the amount of information we store in the log now. And when you're tracking down a certain problem, especially when it's related to networking, it's not necessarily reproducible like this. It may take hours and days to really to reproduce it. And so we don't want you to accumulate all those megabytes and gigabytes of logs. Application log files are broken up into 10 megabyte chunks, 10 megabyte files. So once we fill out the first one, we have 10 megabytes of data for the first one. We close the current file, current log file. We open another one, and we continue until it's full, and we create another one. So with that parameter 90, you can actually limit the number of log files stored on your disk. So if you, for example, if we were, this is the same example with the bug base, we were tracking down this nasty crash that would happen once every week. So it was very rare, but bug base is actually very active in terms of data exchange. So a lot of information was logged. We didn't, at first, we were having like gigabytes of information to analyze. This is useless because when it crashes, most of the time we need the activity within the last 5-10 minutes, maybe the last hour at the most. And with this selector, we were able to tell to Bugbase, hey, look, log the information, log everything, but just keep the last 10 files, okay, the 10 latest files that we need. And if you create file number 11, then the very first one is automatically deleted. So it's rotating like this, and it makes sure you're not eating up disk space, of course. And then once you need to analyze it, you really have the last 10 files to look at. It's very useful. We'll probably go a bit later into the demo with the log files. So what kind of information do we put into the log file? A lot, actually. I'm going to show you just in a moment. But everything goes inside it. And now you can, with the application log, and it's logged both on the client and the server. So on the server, you can tell at which exact moment in time, up to a second, the client has connected, what's the ID of that client, what's the IP address of that client, what kind of threads, what kind of timeouts it sets at the very beginning. You have all the statuses for endpoints. You have socket numbers. You have thread numbers, and you have user IDs, sockets, and threads all associated together. And we also log warnings and errors. So now in the application log file, when you look at the error messages, for example, it's not just it's not like before where we would just log the famous minus 10,003 error or 10,001, which would say just networking error. And that's all that was available. Now we log what thread, what user process, what's the user ID, what's the socket number. And yeah, even if for you it can look kind of cryptic, It can give you an idea which process was doing the work that caused the error. Plus, if you use the debug log together, you can actually associate using the process IDs. You can associate the actual footy method that was running at the time that happened to stumble upon the error. Now, that wouldn't guarantee that that method caused the problem. It's just that while executing that footy method, a networking error happened. So you'll be able to narrow down that part of your code where the error happens. And just one thing I wanted to insist on is all the tools we're giving to you on all the log information, all the new parameters and settings and the architecture, I can understand that just because you don't have the source code of footy, you don't know how it works internally, for you it might look cryptic, but it does have some useful information. It can give you hints, maybe not necessarily how to fix the problem, but maybe you'll be able to figure out, yeah, that method is called way too many times simultaneously on lots of clients, and maybe if I kind of separate it and spread it through time, maybe I'll be able to work around it. And then meanwhile, if it's awesome, if you manage to find a workaround, and meanwhile send the data to us, all the logs and bug reports, that will give us time to work on a proper fix while you sort of use the workaround that you've guessed using the log files. Or maybe we can even suggest to you a workaround. I think you know what, I'll just, let me see if I can show you just an example of a log file. This is as a matter of fact, this is an ongoing problem we're dealing with right now. So that would be a very good example to show you. Actually, let me start with a funny one, just to show you how useful the new log can be. Okay, so this is the log file. Okay, and it's kind of smallish. Yeah, let me just. Show fonts. Let me go to, is it better? Should I go like 24? Can you read anything? Yeah. Okay, perfect. Okay. Yeah, it's going to be multi-line, but that's okay. Let me see if I can make it a bit wider so that all the messages fit into one line. Yeah, awesome. Okay, so let me just, I don't know, take anyone. Oh, great. This is, awesome. I just found the right lines to, okay, so see this part I'm selecting, even this one. Okay, this is pretty much, this is a signature for a new client connection. Okay, so you see this, these messages about local persistent peer ID. It's an internal thing that we use. You don't need to know even what it is. It's just a marker to tell you this is the beginning of a new client connection. I'm not talking about user. This is a new binary, the new client application that's been launched, and it's trying to connect to the server. Then it says, like a connection created. It gives you the task number, it gives you the socket number, and it gives you the peer ID. That's the ID, IP address of the client that's connecting. So you know exactly at what time the client is connecting. So just that few simple lines will tell you what's the status of the application. I don't know how many times I had these problems internally, honestly, with my colleagues, where they would say, hey, I came back to work and I launched my client and I had this error, and I spent hours and hours looking at the server log and there is nothing. And then when we enabled this, I can actually say, hey, look, you came to office. You didn't launch a client. You went to get some coffee. Then you played some pool. Then you played some other stuff. And then you talked with your colleagues. And I saw your client was launched at 11. It's like, don't tell anybody. I started working at 9, not at 11. You see, there's pretty much every single step of the connection is logged. We log when the connection is created, what's the socket number. You see, that's the famous idle timeout. It's sent to 20,000 milliseconds, 20 seconds. That's the default value. Okay, so when you're looking for a particular connection from that given IP address, if you know one of the users is having problems, okay, you know his IP address. Now all you need to do is open up the log file, and then you can see when he connected, what kind of activity he had. Was it like one process or 10 processes? At what time the error happened? But I wanted to show this incredibly funny thing we discovered while working on a completely unrelated problem, but just to show you the power of the new log. So, yeah, OK. So this guy is having, once in a while, when he does a certain action, switches forms, then there is a small inactivity timeout, then he receives certain messages from the server. Basically, there's the whole sequence of things that he's doing. And then eventually, there's a disconnection. So we're working on this problem. But that's not what I want to show you. What I want to show you is, so I got the log from this guy, OK? And it seems kind of normal. There is nothing weird about it, except for this little part. So let's just look at the text, OK? We can just look at the text. So nothing really suspicious happens, because the first one is we resume connection. Resume connection means that there was a connection, OK, which was idling. It wasn't doing anything. So we closed it. And the logical connection is still there, but there is no physical socket. Now, when you see a line says resume connection, it means that that process suddenly needs to send some networking requests. Okay, maybe he wants to do, I don't know, get current time on the server or selection to array, whatever, something that would require data from the server to the client. That's perfectly normal. So we see you have task number. So with the task number, you can actually know what process is running, which method is running, blah, blah, blah. So he creates a task. The connection count goes to 2, then to 3, then to 2, because we kind of, when we switch, when we do resume, it goes +1. All that is, and a few seconds later, he goes back to postpone. See, that's exactly the same socket. If I move this, you should be able to see that it's, come on, where's my mouse? It's exactly the same socket. So basically, a process woke up, it did something, and it disconnected, and it postponed again, so because it has nothing else to do, which is really a routine thing to happen. No activity, we suddenly need to do something, we woke up, we reconnect, we do something, and we disconnect. Now, do you see the weird part about this thing? What? 3 seconds, that's can be OK. Any other suspicious stuff there? Huh? Yeah, that's fine. That's an internal object. Well, the weird part is, look at the time. It's 3 o'clock in the morning. And he wasn't there, and the office is closed, and we don't have security guards going through the top floor. Honestly, I don't know what happened, really. But this is one of those examples where just by accident, looking at some other things in the log, you can stumble into patterns or things just out of ordinary. And even now, honestly, we don't know what happened. Hopefully, we don't have any rodents. We don't have any mice running through the office that kind of accidentally touched the keyboard. I don't know. The only thing I could come up with is maybe he had, I don't know, like a book standing next to the keyboard, and it fell on the keyboard and it touched something. And he says, no, I wasn't there in the office. Are you crazy? I'm not working at 3 o'clock in the morning. But this just demonstrates that pretty much everything is logged now in the log file, and you can see a lot of interesting stuff. Let me show you another example. That's a real disconnection we're working on. That's too big. Yeah, let's go to 24. OK, I'll make it wider to fit everything into one line. OK, let's go to the very back. OK, now see here, for example. I just get rid of this completely. OK, so as I said, we not only we log all the status information, we log all the errors now. And not just like before when you use the old networking layer, you only have the generic networking error and that's it. Okay? Now you have the actual message that explains what's going on. Like in that example, we're trying to, like, see the line above, we're trying to resume connection for task number 7, okay? Which means the task was postponed, there was no activity, and we detect, OK, there is a new request to be sent for this process. So we need to reestablish a connection. So we do resume connection. But then the next line is error. For the client session, we failed to restore connection for that particular task. And then there are a couple more lines, because we're going to try to do it several times to make sure that we really do our best. We try 2-3 times to reconnect, and we fail. And then there's a whole bunch of other warnings and errors. So this is actually the log from the client. Okay, so it was about 10:15 in the morning. Here I have the corresponding log from the server. So the actual case is that internally in the office, we have a QA team, and one of them is permanently having the disconnect messages. And it's kind of weird because they all do pretty much the same thing. Plus, they are on the same subnetwork. So everything is very, very much the same. But she's the only one with this type of errors. So we did some extra analysis to try and figure out what's going on. So here, if we go to about the same time on the server side, 10:15, her IP address is 7.something. And there we go. OK, this is the part. Somewhere from here. This is the interesting part. So see, we have errors on the client side. And at the same time, we have errors on the server side. That's 7.7.52. That's her IP address. OK, so I know this is the error message that actually corresponds to her problem on the server. Because on the server, of course, you have everything, all the IP addresses of all your connected clients. All the messages are mixed together. So we see that the error actually that we failed to exclusively get and use the socket, that's kind of, it's not like a low-level error. It's more like low-level error, which means something's like really, really wrong. And usually this is not the problem on the server. Just by experience, I know this is not really related on the server to the server. And as we saw before, on the client side, it's kind of, the client also has an error. So there is really a problem here. And it's not on the client, it's not on the server. So just with those logs, I can tell, and you will be also able to tell where the problem is, okay, depending on the error message, because the error messages are now very clear. And you'll be able to tell, is it the client that does something wrong with the connection? Okay, and then we can investigate. Is it the server that does something wrong with the connection and incidentally closing the client or dropping the client for whatever reason? Or is it somewhere in between? So in that case, it's pretty much in between. And we went. So what I started to do in that case, I went to the TCP level to see, OK, yeah, that's visible. So in cases like this, I need to really track down who is responsible for closing my connection. OK? And once we go to the TCP level, I know this looks scary and incomprehensible. But we don't really need to understand everything on that screen. This is a Wireshark application. I mentioned it a few times during the previous sessions. This is an application that captures all the TCP packets. Now, the good thing is I don't need to know what TCP packets are. I don't need to know what kind of TCP packets there can exist. All I need to know is there are good packets and bad packets. And bad packets, there's only pretty much one, which is reset. And it has an RST code. Yeah, in this particular example, I filter everything out except for the reset packets. There on the right, do I have a laser? No, I don't. If you look at the two red lines, almost at the very end, you have in the brackets, you have the RST in capital letters. Basically, this is a reset packet. This is a way for the TCP connection to say, OK, this connection is closed, and it's closed in a bad way. So for example, let's look at this example. This is the case where my IP address ends with .6.50. And this is the case where I launched my capture on the client machine. And I just used the task manager to force quit an application on Windows. Okay, I killed the process. Okay, in that case, you see the reset, the RST packets are all coming from my IP address. Basically, it means when I force quit an application, operating system needs to clean up all the resources associated with the binary. Okay, it closes all the file descriptors and it closes all the sockets. So that's actually not us. That's not for the client doing that. That's the OS sending the reset packets to the server, just to let him know the client has crashed. So I'm basically resetting your connection. I'm not closing them properly. I'm resetting them. So this is a red flag. But what actually happened on that QA person's computer was different. Remember, her IP address was 7.52 or something, and this is the capture on her machine. Okay, this is a capture on her Windows machine or Mac, I don't remember. As you see, most of the packets are coming from 177.35.84. This is actually this is our router that's sending the connection abort packets. And this is for me. This is it basically. This is the solution, because I know there is an error on the client. I saw it in the log. There is an error on the server, and I saw it on the log. But what I see, it's not the server and neither the client that's sending the abort packets. It's actually the router that's aborting those packets. And that happens only if you have some sort of really hardware problem. Okay? Basically, the router detects that one of the machines is not accessible, and it cleans things up. It knows that her IP address, 7.52, is no longer accessible. So it will basically close all the sockets. There is no point in keeping the sockets open. And so the ridiculous solution to her problem, and she's been having that problem for 3 weeks, was that, as you know, we moved to the new office. Okay, we're no longer in Clichy. So the whole infrastructure was redone in the new office. And just unfortunately for her, the guy that's installed the actual the box, the socket on the wall where you plug in the Ethernet cable, it was just not properly attached. And when she was moving her legs, she would touch the Ethernet cable, and it would just wiggle a little, and she would lose her connection. But she would lose her connection for I don't know, a few seconds, right? And so she would only see this disconnect message only once in a while, once every 2-3 days. But it's just an example I want to show you that before, I would have to install all my development tools on her machine. Okay? I would have to go into debug mode. I would have to trace the C++ code, log all the extra messages specific to her case, and then analyze that stuff and try to figure out within the code what's going on. Here, I spend overall about a day figuring out what the configuration is and what I can do, setting things up, and getting captures, analyzing the logs. And then just every time that would happen at her computer once every 2-3 days, I would compare the new logs with the old ones to try to see the pattern and compare the captures. And so it took me about a week overall, but the actual effort was pretty much 1 day. So without going into debugging C++ code, any of that, I looked at the client-side log, a server-side log, and Wireshark captures. And I was able to figure out what's going on. So I'm not saying that you should do that too on a daily basis whenever you have the networking errors. But all I'm saying is look at the logs, look at the captures, try to see if you see a pattern. And then when you file bug reports, then please attach those logs and Wireshark captures. And for us, it'll be much more easier to say, hey, try this, try that. So these are the tools. This is everything I have for today. If you have any questions, as usual, I'm late. So I'll be available for questions after the session. And that's it. Thank you very much. And please use the log file.